In this video tutorial, we will learn about the use of the motion sensor to investigate the motion of an object. Okay. In this example here, we will use a ping pong ball, a bouncing ping pong ball, which we will place in between four different vertical rods so as to guide the ping pong ball as it bounces in order for it to bounce along the same vertical line. This is a motion sensor that we bought from Addestation. It sends out ultrasonic waves, ultrasound, and it uses that to detect the position, the proximity, or rather to measure the distance from an object to the sensor. So what we'll do first is to take out the Addestation datalogger, switch it on, and plug in the motion sensor to any of the channels. Okay, so as you can see, the range is between 15 cm to 1.6 meters. Okay, so let's click done, and once we want to start recording, we'll press the start button. Okay, and you position it so you can see both the screen and the ping pong ball at the same time. Okay, so what I'll do is I'll raise the ping pong ball up first before I press start. Okay. So it's capturing. Okay, so you can see the distance of the ping pong ball from the sensor in this graph here. Okay, let's stop. Let's plug out the sensor because it's making a lot of noise. So what we can do, if we like, is to zoom in to look at the graph in greater detail. Okay, so this is the sort of graph you would expect for a displacement time graph of an object that's bouncing. Okay, this is the position of the ground from the sensor. Remember that the sensor is placed above the ground, so the sensor is about 40 centimeters away from the ground. And this is the original position of the ping pong ball. And each time it bounces, the height to which it rises decreases. Okay, this is due to energy dissipation in the form of sound and due to air resistance. The cool thing about this datalogger is that you can differentiate the displacement time graph with respect to time. Okay, so what you need to do is to click on the Analyze button, symbolized by this A here. Okay, so you could choose between different functions such as differentiation and linear regression, but for this example we'll use differentiation. Okay, so once you've differentiated, they show you the velocity time graph in red. What you have is the velocity time graph and the displacement time graph. As you can see, the velocity time graph, it follows a constant gradient. Okay, this is on the way down, and this is on the way up and on the way down, and in between you have a very sharp negative gradient which is at the point of impact with the ground. I can even differentiate it further to give the acceleration time graph. If I may zoom in, the axis here can be changed. Okay, so you have previously we had the displacement time graph, and now it's superimposed with the acceleration time graph. Okay, so you can change the axis to read the acceleration as well. I don't know what this peak is due to, but I think it could be due to the release. When I released it, there probably was a force associated with that. So what you want to pay attention to is the rest of the graph. For most of the graph, what we have is a constant acceleration. Okay, and that's about 10 meters per second square. Okay, which would expect for gravitational acceleration being about 9.81 meters per second square. Okay, so this will be the period during which the ball is experiencing free fall, and it happens quite a few times. Of course, the duration in which it experiences free fall becomes shorter and shorter as the height of bouncing decreases with each successive bounce. That's all. See you next time.